ZK Rollups, a scalable solution. ZK Rollups are a layer 2 scaling solution that improves blockchain scalability and privacy. ZK Rollups leverage zero knowledge proofs to achieve these improvements. Zero knowledge proofs allow for the verification of data without revealing the data itself. In the context of blockchain, this means that transactions can be verified on a secondary layer without requiring all transactions to be broadcast on the main chain. How do ZK rollups work? ZK rollups bundle multiple transactions off-chain, creating a batch of transactions to be processed together. This batch is then processed and verified on the layer 2 network, where the transactions are settled and recorded. The transactions are then committed to the main chain using a zero knowledge proof to ensure the validity of the batch. This proof is a cryptographic method that proves the validity of the transaction batch without revealing the underlying data, which improves privacy. The key benefit of this approach is its ability to significantly reduce the workload on the main chain, allowing for higher transaction throughput and faster processing times. This is achieved by offloading the computation and verification processes that can be handled more efficiently. The use of zero knowledge proofs further enhances privacy by ensuring that the data is not revealed during verification. Let's talk about the key components of ZK rollups. ZK rollups consist of several key components that work together to achieve their scalability and privacy benefits. Understanding these components is crucial for comprehending how ZK rollups function and their potential impact on the blockchain landscape. Rollup contracts are smart contracts deployed on the main chain that manage the interaction between the layer 2 network and the main chain. They are responsible for handling the commitment of transaction batches and verifying the submitted zero knowledge proofs. Zero knowledge proofs are cryptographic proofs that enable the verification of data without revealing the actual data itself. They allow for the efficient and secure verification of transactions on the layer 2 network, ensuring the integrity of the data without compromising privacy. Verifier contracts are smart contracts that reside on the main chain and validate the ZKPs submitted by the rollup contracts. ZKPs are zero knowledge proofs. They ensure that the ZKPs are valid and that the transaction batches have been correctly processed on the layer 2 network. Let's talk about rollup contracts. Rollup contracts are smart contracts deployed on the main chain, specifically layer 1, to manage the interaction with the layer 2 rollup chain. These contracts act as the bridge between the two networks, facilitating a smooth flow of information and transactions. Their primary role is to store transaction data, handle deposits and withdrawals, and ensure the security and validity of all operations. Roll-up contracts are crucial for maintaining the integrity of the system and ensuring that all transactions are processed correctly and efficiently. Zero knowledge proofs or ZKPs. ZKPs are a cryptographic method that allows one party to prove to another that a statement is true without revealing any additional information about the statement itself. This is crucial for ensuring the security and privacy of blockchain transactions. Of ZK rollups, ZKPs are used to verify the validity of transaction batches without exposing the underlying transaction data. ZKPs play a significant role in ZK rollups by providing a secure and efficient mechanism for verifying transactions without revealing sensitive information. They enable scalability and privacy by allowing for efficient batching and verification of transactions on a separate layer, reducing the burden on the main chain. By employing ZKPs, ZK rollups ensure the integrity of transaction data without compromising the privacy of users. This makes them a promising solution for scaling blockchain networks while maintaining the security and confidentiality of user data. ZKPs are a fundamental component of ZK rollups, enabling them to achieve high transaction throughput, improve privacy, and enhance scalability, which is a key technology that drives the efficiency and security of ZK rollups, contributing significantly to their overall performance. Let's talk about verifier contracts. Verifier contracts play a crucial role in the security and efficiency of ZK rollups. They are responsible for verifying the zero knowledge proofs generated off chain by the rollup contracts. This verification process ensures the validity of transaction batch, guaranteeing that all transactions within the batch have been processed correctly and securely. The verifier contract works by interacting with the rollup contract to receive the ZKPs and then executing the verification algorithm. If is a valid, the verifier contract confirms the transaction batch and the transactions are committed to the main chain. This ensures that the main chain is only updated with valid transactions, maintaining the integrity of the blockchain network. Let's talk about the benefits of ZK rollups. Increased scalability. ZK rollups significantly improve blockchain scalability by offloading transaction processing to a separate layer. This reduces the burden on the main chain, allowing for faster transaction processing and higher throughput. By using zero knowledge proofs, ZK rollups achieve efficient verification without compromising privacy. Let's talk about lower transaction costs. ZK rollups can significantly reduce transaction costs by enabling efficient batching and verification of transactions off chain. This reduces the amount of computational work required for each transaction, resulting in lower gas fees for users. These cost savings make blockchain technology more accessible to a wider audience. Let's talk about enhanced privacy after this. ZK rollups enhance privacy by using zero knowledge proofs to verify transactions without revealing the underlying transaction data. This ensures that sensitive information such as user identities or transaction amounts remain confidential. This privacy feature is crucial for protecting user data and fostering greater adoption of blockchain technology. Let's talk about scalability improvement after this. ZK rollups significantly enhance the scalability of blockchain networks by offloading transaction processing to a separate layer known as a layer 2 network. This offloading mechanism allows for a greater number of transactions to be processed concurrently, leading to increased transaction throughput. The main chain can handle a higher volume of transactions without experiencing significant delays or performance bottlenecks. Zero knowledge rollups address the scalability limitations of traditional blockchain architectures, enabling more efficient and scalable decentralized applications. Let's talk about reduced transaction costs. ZK rollups achieve significant cost reductions by processing transactions off-chain. This means that the main chain is not burdened with the computational load of verifying every transaction, which leads to lower gas fees. These lower fees make blockchain technology more accessible to a wider range of users, especially those with limited resources. It also makes blockchain applications more affordable and efficient, boosting their adoption and potential. Let's talk about enhanced privacy. ZK rollups offer a significant advantage in terms of privacy by leveraging zero knowledge proofs. Unlike traditional blockchain systems where all transactions are publicly visible, ZK rollups ensure that transaction details remain confidential. This is achieved through the use of cryptographic proofs, which verify the validity of transactions without revealing the underlying data. This enhanced privacy is crucial for protecting user data and fostering greater adoption of blockchain technology. Transactions are not directly visible on the main chain, improving the confidentiality of user interactions. This contributes to a more secure and privacy conscious blockchain ecosystem. Let's talk about the security benefits of ZK rollups. So, ZK rollups provide a robust security framework, inheriting the security of the main chain while incorporating their own security measures. This combination creates a layered security approach, ensuring the integrity and safety of transactions. One of the primary security benefits stems from the fact that all transaction settlements are ultimately confirmed on the main chain. This ensures that transactions are validated by the underlying consensus mechanism of the main chain, providing a high level of security and immutability. Additionally, zero knowledge proof mechanism plays a crucial role in verifying the validity of transactions without revealing sensitive information, further enhancing the overall security of the system. Let's talk about an example like Loopring. Loopring is a popular and well established implementation of ZK rollups. It serves as a decentralized exchange DEX built on top of Ethereum, enabling users to trade cryptocurrencies with enhanced privacy and efficiency compared to traditional DEXs. Loopring leverages ZK rollups to achieve high throughput and reduce transaction costs. This approach facilitates faster execution of trades and allows users to participate in the market more readily. Loopring also integrates with Ethereum's existing infrastructure, making it a seamless and compatible solution for Ethereum users. Let's talk about some example code. This will be a simple ZK rollup contract. So the following example will demonstrate a simple ZK rollup contract that will showcase the core functionalities of a basic ZK rollup implementation. The contract will utilize a mapping to store user balances and another mapping to track submitted proofs. It will feature three main functions: deposit, submit proof, and withdraw. The deposit function allows user to deposit funds into the contract. The submit proof function enables the submission of zero knowledge proofs, and the withdraw function allows users to withdraw their funds after verifying the proofs. The code snippet provided will illustrate the fundamental concepts of ZK rollups, and it will showcase how proofs are submitted and verified within the contract. The simple contract can be extended to incorporate more complex functionalities such as batching transactions, managing rollup state, and interacting with external systems. So yeah, here's the external code. right? So I'll go through it line by line. So first is Pragma Solidity 0.8.0 specifies the Solidity compiler version to use. Then you're declaring a new contract called simple ZK rollup. Then you're declaring two state variables. Very simple, right? Balances a mapping from addresses to unsigned integer, which tracks the ether balance of each user. And proofs is a mapping from proof hashes to Boolean values, which tracks whether a proof has been submitted. And public keyword generates getter functions automatically. So let's talk about the events. So we are declaring two events. Deposit when a user deposits ether. Withdrawal. This logs when a user withdraws ether. And indexed keyword allows searching for these events by user addresses. So next you have the deposit function here. So what this does is it allows users to deposit ether into the contract, as I already explained before, right? So public keyword makes the function callable by anyone. Payable keyword allows the function to receive ether. Message.sender is the address of the caller, and message.value is the amount of ether sent with the call. So this updates the caller's balance in the balances map. Finally, it emits a deposit event with the caller's address and the deposited amount. Next, you have the submit proof function. So what this does is it allows users to submit a proof. It takes a proof parameter, which is a hash of the proof bytes 32. So public keyword makes the function callable by anyone. Require statement checks that the proof has not already been submitted. And if the proof is not already in the proofs mapping, it adds the proof and sets its value to true. Okay, so finally after that, you have the withdraw function here. So what the withdraw function does is it allows users to withdraw ether from the contract using a valid proof. It makes the function callable by anyone. It takes an amount parameter specifying how much ether to withdraw and a proof parameter bytes 32. Require statement checks that the proof has been submitted and is valid. Require statement checks that the caller has enough balance. The caller's balance in the balances mapping. After that, it transfers the specified amount of ether to the caller, and then it emits a withdrawal event with the caller's address and the withdrawn amount. So, in summary, the simple ZK rollup contract allows users to deposit and withdraw ether. It maintains a balance for each user and tracks submitted proofs. Users can only withdraw ether if they provide a valid proof, enhancing the security and integrity of the withdrawal process. Events are emitted for deposits and withdrawals for transparency and tracking. Okay. Let's see how to use ZK rollups. ZK rollups offer a user-friendly experience for interacting with blockchain networks. The process of using ZK rollups involves a few straightforward steps, enabling you to leverage their benefits for your transactions. First, you begin by setting up a wallet. So you begin by setting up a compatible cryptocurrency wallet. So you choose a wallet that supports interaction with ZK rollups, such as MetaMask or other compatible wallets. Next, you connect to a network. So you connect your wallet to the ZK Rollup network you wish to use. Each ZK Rollup operates on its own dedicated network. After that, you initiate deposits and withdrawals. Once connected, you can deposit funds into the ZK Rollup network and initiate transactions. Withdrawals can be processed back to your wallet after transaction settlements. Let's talk about a few development tools and frameworks. So ZK Sync SDK. The ZK Sync SDK offers a comprehensive set of tools and libraries for developing applications on the ZK Sync network. This SDK provides developers with a streamlined way to interact with the ZK Sync infrastructure, including functions for generating proofs, managing rollup state, and interacting with the ZK Sync smart contracts. Next is Starkware SDK. Starkware provides an SDK for its Starknet platform developers to build and deploy decentralized applications using Stark-based ZK rollups. The SDK offers a range of functionalities, including a programming language specifically designed for Stark proofs and tools for interacting with the Starknet network. Let's talk about other frameworks. So beyond ZK Sync and Starkware, other frameworks are emerging, such as Aztec Network and Polygon Hermes. These frameworks offer various tools and libraries for building ZK rollup applications, fostering a vibrant ecosystem of development. Okay, so let's talk about the challenges of ZK rollups. Despite their many benefits, ZK rollups face a number of challenges. They are computationally complex, requiring significant resources to generate and verify zero knowledge proofs. This complexity can impact performance, especially as the number of transactions increase. The user experience of ZK rollups can be less intuitive than interacting directly with a layer 1 blockchain. Users may navigate multiple interfaces, and understand the intricacies of proof generation and submission. Improving user experience is crucial for broader adoption. The integration of ZK rollups with Layer 1 blockchains can be a complex and require careful coordination. Ensuring seamless communication and data synchronization between the two layers is essential for maintaining security and reliability. Let's talk about the future developments. ZK rollups are rapidly evolving with ongoing research and development focused on improving their efficiency, scalability, and user experience. New proof generation techniques are being explored, aiming to reduce the computational complexity and resource requirements of generating zero knowledge proofs, making them more accessible and practical. Integration with Layer 1 blockchains is another area of focus, with the goal of creating more seamless and efficient interactions between ZK rollups and the underlying main chains. This will involve developing standardized protocols and interfaces, enabling smoother data synchronization and transaction settlement. So now let's compare ZK rollups and optimistic rollups. ZK rollups and optimistic rollups are two popular scaling solutions for blockchain networks, each offering unique advantages and disadvantages. Both technologies aim to enhance scalability and reduce transaction costs, but they achieve this through different approaches. ZK rollups leverage zero knowledge proofs to verify the validity of transactions, ensuring data integrity and privacy. Optimistic rollups, on the other hand, rely on a challenge and proof mechanism where transactions are assumed valid unless challenged. ZK rollups offer higher security and privacy as they utilize cryptographic proofs to validate transactions without revealing the underlying data. However, they require more co- they require more computational power for proof generation, which can impact performance. Optimistic rollups are typically faster and less expensive, but have a lower security guarantee, as they rely on challenges to uncover fraudulent transactions. Let's talk about some real world applications of ZK rollups. So, first is decentralized finance or DeFi. ZK rollups are revolutionizing DeFi by enabling efficient and secure transactions. They facilitate faster and cheaper trading on decentralized exchanges, allowing for better capital utilization and liquidity provision. With enhanced privacy, ZK rollups create a more secure environment for DeFi applications. Let's talk about gaming and NFTs. ZK rollups streamline the integration of blockchain technology within gaming platforms. This enables secure and efficient management of in game assets, such as NFTs, improving user experiences, faster transaction speeds, and lower costs for gamers and developers. Payment solutions. ZK rollups enhance the efficiency and security of cross border payments. By processing transactions off chain, they accelerate transaction speeds and reduce costs associated with methods. With their privacy features, ZK rollups enhance user security and confidentiality during financial transactions. So, finally, conclusion and next steps. ZK rollups represent a promising solution for scaling blockchain networks, enhancing privacy, and improving transaction efficiency. They offer a significant leap forward in the blockchain landscape. I encourage you to delve deeper into the world of ZK rollups, experiment with different implementations, and contribute to the development of this innovative technology. Stay informed about the latest advancements and explore the potential of ZK rollups to revolutionize blockchain applications. Thank you very much, and I'll see you in the next one.